Hello all, C3 here. So I've got a new video here today. This one is of a Packard Bell multimedia, as you can see in front of you here. Naturally we're going to be opening the thing and cleaning it out, but first, before we do that, here's just a quick look around the side. Yeah, you can see quite a bit of dirt in places, particularly on the front, some near the power supply on the back there though. Um, if you may notice, the focus is kind of out of whack here. I did find a fix for this, but I unfortunately was not able to apply it until closer to the end of the video. The issue was that the camera app that I'm using has continuous focus, and it sucks. So I stopped using that. As I get the thing tipped up here, we'll be able to see that the model number of this Packard Bell model multimedia is an A940 4x4. And it's factory remanufactured. I don't know if that was a common thing with these Packard Bells or what, but as of the time that I'm recording this, I now have two, possibly three of these remanufactured Packard Bells. So anyway, getting the case off of this thing is just as easy as undoing three screws around the edge like so. And obviously it's going to take me units to get through those, but you can see them all there. As we'll see later in this video, this computer has already been opened, so it's not like I'm violating the integrity of that warranty seal there. It's already long been cut. So now with all the screws off, the case just sort of slides back and up like a lot of other clamshell case designs, and we get a look at the internals. A lot of cable mess in the way, so you can't really see too well what's going on in there, but the first thing that ought to catch your eye is this nice little sound card in the front here. And that is one of these typical Packard Bell branded modem sound card combo things. I think they are underlying sort of a Sound Blaster type thing, but and getting down in there we can see the absolutely abhorrent Dallas RTC chip, and it's of course soldered to the board. So that's another thing that we're going to be tackling in this video, is getting that boy fixed. And you can see, well, I'm showing this off here, we've got two hard drives in the system. It's a little hard to tell because of the weird camera angle, but yeah, you can see that that drive's mounted on 5 1/4 to 3.5 inch adapters, so that's not original. But hey, okay, so as we get this computer disassembled here, here's a little bit of a better look with still destructed focus at the Packard Bell sound card. And as I thought it might have been before, it's not a Sound Blaster based card, it's quite clearly an analog devices based thing. So yeah, obviously this is going to be already pre-configured for the correct settings. And here's a look at the back with not much to speak on there, just a single little nut for a transistor on the top, and a grade B sticker, which might have to do with the remanufacturing, who knows. Okay, next bit on the agenda is getting the CPU out of the socket. It's just got a little clip to retain the heatsink on there, with some of that absolutely disgusting thermal goop. And it's a nice gold top Pentium. This thing is a 60 megahertz Pentium. And as we get it out of the socket here, we can flip the thing over, and once the camera decides it's going to be focusing, we'll see that it's an SX948. I looked it up, and this is not an FDiv bug Pentium, so yay. I was kind of hoping it was, actually, but that's alright. Okay, and now we're back around towards the front of the case. We're going to start working on getting the drive carrier thing out, which holds the floppy drive, CD-ROM, and two hard drives in place. This is sort of like the deck PC that we did before, except the hard drive and CD-ROM things are all contained in one. And there's three screws to get that detached from the rest of the case. And once I get all of these screws out, you'll see that it does slide back with quite a bit of effort. It even goes so far as to pull the front of the floppy drive off a little bit, which was sort of annoying, but that's alright. It just pushes back on there, and then we managed to get the thing out and flip it over at which point we can take care of getting all of the cables out. So once we actually get all those cables out, we can actually just get the whole drive cage up and out of the way, and we can get a slightly better view of the front of the power supply. And in that, we can also get a better access to the power cables for the motherboard. So once we get those out, the only thing stopping us from removing the power supply at that point is the power button on the front and the 4 screws on the back. But before we have a go at the power supply, we might as well go ahead and start taking the motherboard out. So naturally, the first thing to do is get all of this whole mess of cables out of here, and I made sure to, take some good video of this, because these are just bare connectors on board type of thing, and you have to, well, if you don't want to look at silk screen, you have to remember which orientation the cables go in when you plug them in, otherwise you do have issues. So in order to get the motherboard out, we obviously have to get this riser card out, and in order to get the riser card out, you have to get the bracket sort of thing out as well. And the way that attaches is just one screw at the end, which we unscrew here. And once we get that unscrewed, it kind of just lifts off the riser card, pivots out a little bit, and then it removes. And once we have that out, getting the riser card out is really just as simple as ripping the thing right out of the socket, like so. And there you can get a look at that beefy connector, sort of a EISA type connector, obviously proprietary. But yeah, once we get that thing out, we have pretty much perfect access to the motherboard. Just got to get those power cables out of the way, and then we're going to go ahead and remove the chip from the board just to protect it. Don't want that thing getting damaged. It's not like I have a bunch of gold top Pentiums laying around. And then once we get that guy out, all we have to do is unscrew the motherboard, which is accomplished with 7 screws. And once we get that 7th screw out, I thought this was going to be super easy to remove. It would just slide back all nice. But actually what happened is 2 of the screw holes have these, I don't even know how to phrase it. They have like bevels on them, basically, that inserted up into the screw hole and made it feel like there was something on the underside holding the motherboard. So it actually just took more force than I was expecting to get the motherboard up. But once I actually figured that out, it was quite easy to get out. Now we skip ahead quite a bit. We've got the Dallas RTC chip already desoldered. And this is a little bit of a weird one because the not all of the pads on the motherboard were populated, despite what you may think. Some motherboard designs do populate all the pins, even though not all of them are used on the Dallas RTC. So what I wound up having to do with the socket that I planned to put in there was actually cut some of the pins off in order to be able to solder it in there at all. And so now you can see I've actually got the socket in the board, and I just need to solder it in place. And so now, as you can see here, I've got the socket soldered in place. Okay, and onto the Dallas RTC chip itself. I've naturally scraped away the side bits there and exposed some metal pads, which I can solder a CR2032 holder out to, which is honestly, in my opinion, despite having to do the mod, the better solution in the long run. Because I mean, you can replace the chip, but after a while, you're going to be right back to square one, basically, of having a dead battery in your chip. Whereas this solution, you can just replace the battery instead of replacing the chip. It just seems a lot better to me. So now you can see here that I've got the actual CR2032 holder soldered on there. I obviously just run a wire over to the other side to connect the other thing, and then just solder the one leg directly onto the Dallas. And so now you can see the final result here. The Dallas RTC chip with the CR2032 mod is in the board, and this dead battery problem is solved. Alright, so back to the case. Those 4 screws holding the power supply in also held the back plastic cover on, which just sort of slid off after we got that got the screws out. Now the only thing to remove is the front power switch. So this front panel is a little funky to remove. This little gray plastic piece sort of slides down, which reveals 3 screws. Once we remove those screws, that removes the front panel. Once we lift that front panel up and away, we can get actual access to the power switch and the front panel LEDs as well. So just 2 screws holding the front panel LED things in place, and then we can fish those cables up and out. And 1 screw to remove the power connector, and that removes the power supply as well. So with all those bits out, the power supply comes out nice and easy. I'm not going to show the entire cleaning and reassembly of this PC. You know, it's just the reverse order of taking it apart. So I'm going to skip this and we'll be back together. Okay, so here we are with everything reassembled. Now the only thing we need to do is put a fresh CR2032 battery into the thing, and we are ready to start this computer up. So naturally we do, and no smoke has arisen yet, and hey, we get a nice post screen. So we go through post, we get a nice detected C drive and a D drive, and we get the obvious CMOS checksum errors, and then we get a password prompt. Okay, so pause here. This issue stymied me for quite a while. So we booted up first, obviously, with that CMOS checksum invalid, and then we got the password thing. The first issue is that no password should have been set on that. Not only did the CMOS settings get completely cleared, but the battery had been out of it for some time, so that was very, very weird. I eventually tracked down the jumper to clear the CMOS password, which was not easy to find in the slightest. And once we were able to actually get into the system settings, it would immediately freeze. The entire computer would lock up, and you'd have to reset it. So I was under the impression that I had broken something in the process of desoldering and resoldering the Dallas RTC chip. So I took the whole motherboard out, I checked over my solder joints, I redid them all, I checked continuity between the top and bottom, I even tried a new Dallas RTC chip with a better battery and another one that I had modded, and none of those worked. So I posted a post on the vintage computer forums, and that was really of no help. So after some Googling around and no luck, my last ditch effort, really, and it was just a complete idea out of the blue, so I'm shocked it even worked. I popped a DOS boot disk into the thing, and once I got that password prompt cleared, it was perfectly fine to boot into DOS. I set the date, I rebooted, and I got into the BIOS. It worked. So once I had actually reported that I got that issue solved on the vintage computer forums, basically a guy chimed in and said that probably the issue was they expected the BIOS manufacturer expected part of the clock to be initialized. Like, just, it had to be initialized. And because it was not, it completely locked up the BIOS. So basically there was like a null value or some sort of invalid value in the date that it could not deal with when going into the BIOS, and it locked it up. So if any of you, whether it's a Packard Bell or some other computer, run into some stupid issue where your BIOS is locking up, try setting the date. Such a dumb issue. So with that issue out of the way, we move on to OS install. I naturally wanted to wipe out what was on here, so I went ahead and found a installation of, Packard Bell restore of Windows 3.1, basically. Since it would have been probably the original OS that was installed in this machine, and here we are running that now. Okay, so now we move on to the second part of the Packard Bell restore, which is restoring the actual Windows 3.1 and not just the DOS. So naturally, booting off a MS-DOS floppy here. I've got the CD-ROM in the drive. We've got the floppy in the floppy disk. And here we go. We're loading up the Packard Bell Master Restore diskette, loading the CD-ROM driver, and oh, okay. No drives found. Okay. Yeah, so on the previous install, there was in this machine, there's uh, basically a special Matsushita CD-ROM drive that hooks into the sound card. And that required a special driver. Luckily, I had a carbon copy of the install that was on here, so I was able to steal that CD-ROM driver out of the previous install. But in order to get this going, I simply cheated with a normal CD-ROM drive hooked into the actual IDE interface. So once I actually put that in there, I was able to run the Packard Bell Restore, and it found the CD. So, yay! And so once that restore had finished, we were able to boot up into a nice, fresh sort of Windows 3.1 install with the Packard Bell Navigator and all. Now, I did do some further software installs after this, including, zip drivers, Microsoft Works, and some other stuff like that, which is not shown here. The last thing I want to do in this video is probably sort of a new segment that I'm going to do, which is benchmarks. Okay, and so the benchmark tool set that I'm using is one that was compiled by Phil's Computer Lab. I'm just copying it off of zip disk here, and I will tell you what benchmarks we're going to be running in the next segment. Okay, so here we are with the benchmark list in front of us, made by Phil's Computer Lab, as you can see up there above. We're going to be doing 5 benchmarks in total from this pack. We're not going to be doing all of them per computer. We're going to go Speed Sys 4.78, which is the first benchmark that you can see above right now. The second benchmark we're going to be doing is Landmark Landmark Benchmark 6.00. The third benchmark we're going to be doing is 3D Bench 1.0C, and the fourth is the PC Player benchmark. There's a fifth, which is going to be the Doom benchmark, but I'm not really completely sure how to count that. The reason being is because on faster computers, the amount of real ticks that occur is less than on an older, slower computer. So, yeah, it's a bit funky on how to count that. If I find a way to do it, I have all this info saved in a text document, so I can just pull that back up and add it if need be. So, and yeah, as we can see in the SpeedSys benchmark here, we've got a rating for our 60 megahertz Pentium of 44.28, which is equivalent to an AM586 133 megahertz, which is quite interesting. And what I'll be doing for these benchmarks is I'll just be running each of them 3 times, except for Landmark, because it is a continuous benchmark. We'll just take whatever the average reading appears to be, assuming it holds steady. But yeah, other than that, here's the first run of it. As you can see, this computer is equipped with L1 and L2 cache, so those are running pretty good there. And so here we are getting into the Landmark benchmark. I don't think I mentioned before, but we are going to be booting into a DOS boot disk of some kind, just to eliminate, most driver loading things in these benchmarks. But as we can see there, we have a 483 megahertz AT, which is pretty cool. And now we're moving on to 3D Bench 1.0C. And you can see there's 2 versions of the 3D Bench. There's 1.0 and 1.0C. The only difference is that 1.0C can go up to 999 frames per second, whereas 1.0 can go up to 99. There is a slight performance difference between the two, but I don't really think I particularly care. So as you can see there, we're just getting in there to run 1.0C now. And this is just to show the performance difference, but for any computer, whether it's old or new, I'm just going to be using the 1.0C benchmark. If for some reason I can't get the 1.0C benchmark to run, we're probably just going to divide it into a separate category. I don't know if there's any incompatibilities. So the last benchmark that we're going to be running, well, second to last, is the PC player benchmark. And we can see that running here. Not too much eventful. Just goes through the steps and then gives us a, I don't know if it's a score or a frame rate, but it gives us one of those two at the end. And so we can see there at the end of the benchmark we have a score of 17.3. So then the last benchmark we're going to be running is the Doom benchmark. But I'm probably just going to fast forward through that since, we're not really counting the results anyway. Okay, so as I let this clip play once again, let's go over the scores for our Packard Bell Multimedia A940 4x4. For the Speed Sys benchmark, we had an average of 44.28 on the CPU score. I'm not going to be counting any of the L1, L2 cache or memory throughput scores into the final calculation. We're mostly focusing on CPU performance for these particular benchmarks. For the Landmark benchmark, we got a score of 482.55 MHz. For 3D Bench 1.0C, we got a completely rock solid across all three tests of 56.2. And same deal for the PC Player benchmark, where we got 3 consecutive runs of 17.3. So the method that I'm using to calculate the final benchmark score is literally just adding up all the CPU scores. So 44.28 plus 482.55 plus 56.2 plus 17.3, and that gives us a final score of 600.33. So, without a doubt, this Packard Bell A940 4x4 is the fastest computer that's ever been featured on this channel. But wait, I actually got the old digital PC 5000 out from the last video. Yeah, because I kind of wanted to have 2 results and not just the one. So the digital PC 5000 got a CPU score in SpeedSys 4.78 of 227.16. It got a Landmark 6.0 score of 2,615.26. It got a 3D Bench score of 200.8, a PC Player benchmark score of 60.8. And that leaves us with a final score for the digital PC 5000 of 3,103.99. So, yeah, the digital PC 5000 kind of blew the A940 4x4 out of the water. But that's to be expected because the digital PC 5000 has an AMD K6-2 in it at 200 MHz, whereas the A940 4x4 only has a Pentium, not even an MMX Pentium, at 60 MHz. So, yeah, maybe the A940 4x4 isn't exactly the fastest computer that we have on the list, but it is the fastest Pentium on the list. So that's pretty cool, I think. Well, yeah, I mean, certainly these benchmarks as they are right now don't really tell much of a story. So, as we go along, we're going to be adding computers that are in my collection to this list, and hopefully, over time, we should have a nice little rankings chart for things. Obviously not anywhere, scientific or anything, just kind of a rough benchmark for each PC that I have in my collection. So, yeah. And I think probably for 8086/286 based computers, I'm probably going to have to do benchmarks differently. But we'll get to that point when we get to that point. So, yeah. But I think other than that, that's about all I really wanted to do for this video. So, yeah, I mean, probably a little bit of a shorter one, kind of rushed. I'll give that to you. But hopefully you enjoyed regardless, and hopefully you'll stick around for my next video, which should hopefully be a little better than this one. So, yeah. Thanks for watching, guys. Have a good one.